So, we're going to do the product rule and quotient rule here, and then we'll also get into higher order derivatives as well. So that's like second derivative and so on and so forth. That's the goal, at least. Hopefully we'll be able to get all that done. Alright, so before we just jump right into the rule, which is just no fun, alright, we're going to consider f of x equal to x squared times x to the fourth. Okay? And what we're going to do is find the derivative. Okay? Using the method that we know how to do, find the derivative. Okay? So what I mean by that, right, is with what we know, except for Miss Steinfeld's students, right, except for what we know, can we find this derivative with the way it's currently written? No. So you need to rewrite it and then take the derivative. So go ahead, take 30 seconds and do that real quick.
On quizzes, should we rewrite derivative and then find out rules? Like, should we rewrite it?
You should show the work, yeah. If it's multiple choice, I'm not going to look at the work at all, so you do whatever you want. But if it's for a quiz, since I don't do really a whole lot of multiple choice in that, then yeah, I would show. Okay. All right. So, Connor, how should we rewrite this?
What we would do in the Steinfeld class, we would do using these.
Okay. Right. So we're not going to use product rule here. How do I do this without product rule? If I want to use my, I think so, right? Were you starting to describe a product rule thing or no?
Yeah.
So no product rule. Without product rule, how we have to do this, which might be difficult because that's what you know now. But how could we rewrite this? The function. What else could we say f of x is equal to here? When you have x squared times x to the fourth, what does that equal?
That equals x to the 6.
Yeah, x to the 6.
Oh.
There you go. Okay. And so then f prime of x based off of that is what? 6x to the fifth. So we know the derivative, and this is using our current, so this for everyone else, this is our current rules, right? So using our rules, we had to rewrite this first, that we know, and then we had to take the derivative, 6x to the fifth. So the derivative of this thing must be 6x to the fifth, right? Must be. Okay. Now what I would like you to do is now take the derivative, okay, of each term and multiply the two answers together. All right? So what I mean is, right, we have f of x equals x squared times x to the fourth. And I want you to take the derivative of each of the individual parts of the product here. Okay? So the derivative of x squared is going to be what, Ryan?
2x.
2x, right? So we're going to see, is f prime of x equal to, so it's going to be 2x, and then the derivative of x to the fourth, Ryan?
4x cubed.
4x cubed. Okay? And so if we look at this, and we simplify this out, let's see, 2x times 4x cubed, all right, is going to be what here, Mac? What is 2x times 4x cubed? What does that simplify to be when we actually multiply it out? That's okay. It's like a 60-year-old woman. 8x to the fourth. That's right. So that's okay. I'm a little funny myself, too. I get that as well. Okay? So, is it true that the derivative with respect to x of g of x times f of x is merely equal to f prime of x times g prime of x. Is that true? No. How do you know? What did we just do to show that? Right, these two derivatives are not equal, right? This first one, we did it the correct way, right? The way that we know how. We had to multiply these two things together and then take the derivative of it to get 6x to the fifth. Here, okay, we're like, oh, maybe there's a shortcut. Maybe, like addition, like subtraction, we can just take the derivative of the individual parts and then multiply those two parts together to give me the actual derivative. But that doesn't work. Clearly, these are not the same thing. They're very different. Okay? So, you can take the derivative of individual parts if you're adding or subtracting, but you cannot take the derivative of individual parts if you're multiplying. Okay, and then just multiply the two parts together. So, how do we do this? Well, this is where the product rule comes in.
So just get your laptops a little bit that way.
Oh, sorry. So, the product rule. Derivative with respect to x of f of x times g of x. Okay? Is equal to f of x times g prime of x plus g of x times f prime of x. Who came up with that? There is like there is a way to kind of like prove it or whatever. So, but I didn't want to go through that. Actually, I don't know it off the top of my head. I have to look it up. But I mean, there is a way to derive this. I'll say, come up with it. Right? I don't know. I couldn't say. Okay, it is pretty crazy. Okay.
This is Mr. Big Mr. Big
Okay, so this is something you will need to have down, i.e. memorized. You need to know it, okay? You need to know it. How did I learn it? I sat and I looked at it and I memorized it, okay? The way I memorized it is I called this thing the first, okay? I called this thing the second, and so it's the first times the derivative of the second plus the second times the derivative of the first, and that is how I remembered it to this day, okay? Whenever I have to go to the product rule in my head, I'm like, first times the derivative of the second plus the second times the derivative of the first. Basically what you're doing in the product rule is you're taking the two pieces, you take the derivative of the one piece and multiply by the original of the other piece, and then you swap it. You take the derivative of the other piece and multiply by the original of the other one there. Okay, so it's like you're just taking turns multiplying the original times the derivative and then the original times the other derivative. Okay, the other original times the other derivative, basically. Okay. There are some that do like UV. I think Miss Steinfeld showed you guys this. So, Ms. Steinfeld says that this thing is like U and this thing's like V.
Why would you use U and V?
U and V are like...
That's a horrible idea.
I understand because they do look very similar, right? And then she has you guys like write out like a U prime, a V, and a V prime. Okay? And then it's this times this, and then this times this for the product rule.
We don't have to know that, do we?
You don't have to use it that way if you don't want to. No. But I mean, it's organized to work better. It's up to you.
If I do, I'm not going to get
Yeah, me too.
You're good at handwriting, man.
Right, you can use A and B if you want to, but this is the basic idea of it. And I'll show it both ways. You can make up your mind about which one you want to use here. In fact, let's go ahead and just try this. So let's go back to our original and see if this actually works. So let's find f prime. Okay, if f of x is equal to x squared times x to the fourth. Okay. So again, you might look at this, and say like, well, wait a minute, Mr. Meyer, why do we even need the product rule, right? Because like I could totally just multiply x squared and x to the fourth together and then take the derivative. And you're right, you could in this case. So let's find f prime of x. Okay, so I'm going to do it my way, okay, and then we'll take a look at and the other way with Miss Steinfeld and stuff like that, okay. So just my way, okay. So again, the first function here is what? X squared, and the second function is what? X to the fourth, and so it's going to be the first x squared times the derivative of the second, which is going to be what? 4x cubed plus the second function, which is x to the fourth times the derivative of the first, which is 2x. Okay? Wow. Fun.
Wow.
So, x squared times 4x cubed, 4x to the fifth. Yes, you need to simplify this. X to the fourth times 2x, 2x to the fifth. And then we have like terms, 6x to the fifth. Okay? And a free response question, if you were asked this, you could stop right there because you've taken the derivative. But again, for your homeworks, for your multiple choices, you need to be able to simplify down to, you know, like normal simplification rules, okay? Because you got to be able to match this in the multiple choice there. Oh, sorry, I see that. It's scooted out of the way there. Okay?
So there's no actual difference between your way and the other way other than
Nope.
how you're naming it?
So let me show you just the other way here, okay? I'm going to use U's and V's because that's what, Miss Steinfeld uses U's and V's, right? So we're going to use U's and V's, okay? For A, B, B, C, it has a little bit more meaning because they learn a different, like some other rules later on that use U's and V's. Anyway, but we'll say. So there's our U, there's our V, and so U equals x squared, and then U prime would be 2x. V equals x to the fourth, so V prime is going to be 4x cubed, and then you just do little arches, and so it's x squared times 4x cubed plus 2x times x to the fourth. See if you get the same thing. Okay? I don't care which one you use. It's up to you, whichever one you want to use. I will not be using this one in my notes generally, okay? I'm going to be just doing the way that I did it because that's what I do. But if you want to use this, feel free to. I don't mean to hate on this, okay? And if like you want to ask me a question about using this, I will be happy to, you know, relate the problem to this, okay? And I'll be happy to help you through it if you need some help with it. But like I said, I will be doing it just with the first times the derivative of the second plus the second times the derivative of the first, because that's the way I have it down, okay? But again, we get 6x to the fifth, which matches all the way back up here with what we should have gotten, right? So, there we go. Questions on any of that so far? All right, we'll do some here then together. Find the derivative of the following. Okay. So the first one we'll do is h of x equal to 3x minus 2x squared. That quantity times 5 plus 4x. Okay, so h of x is equal to 3x minus 2x squared times 5 plus 4x. Sorry, I'm off the screen there. Okay, there we go. Okay. So again, clearly I'm diminishing some of the difficulty of this kind of problem. Like, we don't get to fully appreciate how difficult some of these problems can be because it's in the product rule notes. So you already know that you need to use the product rule. Sometimes, though, when you're out in the wild doing problems, okay, you're going to come across something like this and you're going to look at it and say, oh, I just take the derivative. It's going to be 3 minus 4x times, 4. And then I'm done, okay? This is a little bit a little bit easier for you guys. I'm kind of setting it up a little bit more because it's in the product quotient rule notes, okay? Do we have to use a product rule here, though? No. If I didn't want to use a product rule, what would I have to do here? Yeah, FOIL it out and then take the derivative of that trinomial, okay? Whatever it would be. But let's use the product rule since we're in the product rule notes, okay? So let's see here. It's going to be the first thing, so 3x minus 2x squared times the derivative of this second thing. Okay, and what is the derivative of this second thing here? 4. Plus the second, so 5 plus 4x, times the derivative of the first, so that's going to, what's the derivative of the first thing? 3 minus 4x. There we go. We should be able to, yes, and so I'm going to do that. So we should be able to FOIL this out, potentially. I mean, you could stop here, because you've taken, I got to be careful here. Okay, so please also be careful, guys. If you have h of x equals this, and then you just have an equal sign, Okay, like if you have the equal sign with just, so you're saying that h of x is equal to this thing. H of x is not equal to this thing. This thing's the derivative, so you need to label it as such. It's the derivative. Okay, do not be lazy with your notation and stuff too. Okay, so we distribute the 4 there. It's 12x minus 8x squared plus, and we have to FOIL this out. So 15 plus 12x minus 20x minus 16x squared. And let's see here, combining like terms, we get negative 24x squared. 12 and 12 is 24 minus 20, so plus 4x. And then plus 15. Okay, so there's our derivative. Okay. Questions on any of that? We're all good? All right, B. Let's try another one then. Y equals 3x squared e to the x plus sine of x minus 3. Okay? Is there even a quotient rule in here, Maya? Is there even a quotient rule in this problem? Or not quotient rule, sorry. Is there even a product rule in this problem? Sorry. Is there even a product rule in this problem? Yeah. Guys, this is a product rule right here. Okay? It's not the entire problem is not a product rule, right? But 3x squared times e to the x, that is a product rule. So you need to keep your eye out for that, okay? This is like kind of a little innocuous, little x squared next to an e to the x. You're thinking, oh, it's just going to be 6x e to the x. This is a product rule, so you have to treat it as such. Okay, now there's kind of two different ways to tackle this product rule. The one way you can tackle the product rule is to kind of consider the first thing to be like 3x squared, and the second thing to be the e to the x. Okay, so the one way to do this is to go y prime equals, and then you would do the first, 3x squared, times the derivative of e to the x, which is what? Yeah, easiest derivative of my life, okay? Plus the second, e to the x, times the derivative of the first, 6x, bless you. Okay? Now that was just the product rule, but are we done taking the derivative? No, what are we supposed to take the derivative of? Sine of x. Derivative of sine is cosine. Okay, by the way, guys, if you don't have those down, you better have them down by Monday, okay, because they will be on the quiz, I guarantee. And the derivative of minus 3 is what? 0, so it's gone, okay? And so our final answer here for this derivative is going to be 3x squared e to the x plus 6x e to the x plus cosine of x. Okay? All right. Questions on any of that? Anything unclear or unsure about why we did something? Okay. This is where things get complicated. Well, it's already been kind of complicated, but it gets a little more complicated now because we're like opening up the number of problems we can now do. All right. I told you there was another way to do this one, so let me show you that right over here. I'm going to do it like down here though, so that we have some more space. Okay. Alternative to this is we can consider the 3 kind of pulled out front. So we could like consider this thing to be 3x squared e to the x like that. Okay, we can kind of consider, and so the 3 as a coefficient, we can just leave that out and just treat the product rule as being x squared times e to the x. Leaving the 3 out. So that means our derivative, y prime, would be 3 parentheses, so the 3 is pulled out, but it's still, obviously continues through to the derivative, and then it'll be x squared, the product rule of x squared times e to the x. So it's the first would be x squared times the derivative of e to the x, plus the second e to the x times the derivative of x squared, which is just times 2x, plus cosine x, of course, for the derivative of sine. Okay, now if we simplify that, it's 3x squared e to the x plus 2x e to the x plus cosine x. And then, of course, we can just redistribute that 3 and get the same thing we had right there. So you see, you get the same thing. So it's up to you to choose whether you want to consider the 3 to be part of the x squared and then have it be part of the product rule, or if you pull the 3 out and then just do the product rule on the x squared e to the x. It's up to you. Both are equivalent. Okay? Questions on that? We're all good? All right. Moving on. That was the product rule. Now we're ready for the quotient rule. Okay? Emma already knows the quotient rule. Emma's probably got the song memorized at this point. Emma's not paying attention though, so she can't hear me.
She's really not.
I know she's not. I know, yeah, I know. Literally.
Actually,
No idea. Okay.
We've been talking about you for like the past.
I know, I can hear. I was laughing at something else.
All right, so now let's consider, in a similar fashion, right, we'll consider f of x equal to x to the 6th over x squared. Okay? Find the derivative. Okay, so go ahead, take 30 seconds. Do this derivative as we know how, using our current skill set. Find the derivative of this, please. Okay? So, Drew, what'd you get for the derivative?
Negative 2x to the negative.
What? No.
What?
Boy. Huh?
Yeah.
Ah, okay.
I think you've done this.
So, we can't take the derivative as it's currently written, right?
Yeah,
What'd you do?
I took the x squared up on the numerator and made it.
A product rule?
Yeah, but then I forgot to do the product rule.
Oh, you just did the derivative of the individual pieces. Okay, so you could have made it a product rule and done it that way. That is correct. I mean, that's not wrong, but of course, yeah, you have to use the product rule though, and not just the individual pieces. Okay. So again, you see though how just something so simple as this can actually get kind of complicated if we're not careful with our rules and stuff. So anyway, the way we would know how to do this is doing the division here. So f of x equals x to the 4th, which then means f prime of x, Drew, would be what?
4x to the 3rd.
That's exactly right. Okay, so this is what our derivative should be. Okay, now, let's find f prime by taking the derivative of the individual parts and dividing the answers. Okay, so find f prime by taking the derivative of the individual parts and divide the results, or dividing the results. Okay, so if we do that, then Chanda, what's the derivative of x to the 6th? X to the 5th, that's right. And then over, and then what's the derivative of x squared? 2x, which this simplifies, doesn't it? 6 divided by 2 gives us 3, and x to the 4th. Okay, so, these two things do not match up. Okay, so, just like in the last one, okay, is it true that the derivative with respect to x of f of x over g of x is f prime of x divided by g prime of x? Is this true? Right. No, it is not. Okay? It is not. So, how do we take the derivative of a quotient? Well, we use the quotient rule. Bless you. So the derivative with respect to x of a quotient, like f of x over g of x, is equal. This is you think the product rule is crazy, Brandon? Just wait to see this. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared.
So this is just like a...
Oh, I'm sure. I think, in fact, I probably took that class in college, I would imagine. But how these were derived, how these originated. Okay? Notice here that in the quotient rule, we have subtraction in the numerator. Okay? Whereas in the product rule, it was addition. So if you mess the order up here, in the product rule, for example, if I accidentally did g of x times f prime of x plus f times g prime, is that okay? Can I flip the order around here with addition? Yeah, 2 plus 3 is the same thing as 3 plus 2, right? So that's not a problem. Here in the quotient rule, if I mess up the order of my numerator, is that going to be a problem? Yeah, because 3 minus 2 is not the same thing as 2 minus 3. So it's got to be the bottom times the derivative of the top first, minus the top times the bottom second, all over the bottom square. Okay? That's a lot to remember. But again, that is how I memorized it. In my head, I would just look at this over and over again. I just repeat it. The bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Boom. And that's how I remembered it. And I still remember it to this day. Of course, I've been, practicing it in high school repeatedly with you guys over and over anyway. But anyway, I still remembered it. Okay? Never forgot it. If this is too much for you to remember, there's also a little rhyme. Ready for this? So if we call this thing the high, I'm just going to spell it H-I because I'm lazy. And this is low as in L-O, right? It's the high thing, it's the numerator, it's in the top. This g of x is the low thing, it's in the denominator, it's in the bottom. Okay? You say low d high minus high d low over the square of what's below. Okay?
Wow, Drew, that was
Low d high minus high d low
I'm seriously gonna be like, all the codes are gonna be like,
over the square of what's below. It sounds like an Irish kind of limerick thing or something like that.
That is fire.
can I get Betty White?
17, 31.
So there you go.
That is awesome.
Okay?
I'm never gonna get this ever.
There you go. You sing it in your head. Okay, so there it is. Okay?
Did you move ahead?
We ready?
For me.
Alright, so it works. I'm not going to go ahead and do that previous one. I want to just jump into some problems here in the interest of time, which we are running out of. Find each derivative.
That is a great mnemonic.
Okay. Okay. So whereas before we were able to rewrite x to the 6 over x squared and find that derivative, we cannot just find this derivative simply using our power rule, right? There's no way to rewrite this in a format where we can take the derivative unless we use the quotient rule, right? That's our only option here. The only thing we can do is use our quotient rule. So f prime of x is equal to, okay, the bottom here, x squared plus 1, times the derivative of the top, 5, minus the top, 5x minus 2, times the derivative of the bottom, 2x, all over the bottom squared. you don't have to FOIL the bottom out. In fact, I would not FOIL the bottom out. Okay? I would leave it unmultiplied. Because then if you, well, yeah, I would leave it unmultiplied. No need to FOIL it out. But we do need to simplify the numerator, though, for sure. So 5x squared plus 5. But that was it. That was the calculus. That's like 50% of the battle. The rest of the battle is making sure you simplify everything correctly. Okay? For example, this minus sign is going to distribute to the 5x and to the minus 2. Or as I did, I distributed the 2x first. Still leaving the parentheses, though. So you get 5x squared plus 5 minus 10x squared plus 4x all over the quantity x squared plus 1 quantity squared. And so then we get a negative 5x squared overall plus 4x plus 5 all over x squared plus 1 quantity squared. At this point, you could try to check to see if the numerator factors at all, but it's clearly not going to cancel with one of these factors down here, so I would say just leave it as it currently is. There's no need to. Okay, it won't factor. It won't cancel with x squared plus 1 for sure. So over the square, what's below? Yep. So if that helps you remember it.
Never gonna happen.
I'm going to write that down. Austin will never go on these ways.
It's not gonna happen.
Or at least not for...
Watch, he gets it. He like messes up on like the
arithmetic part.
Yeah.
Arithmetic on it.
Limit of a versus 0 of loading on my side. Oh, gross.
Okay, next one.
Oh no. I don't like that. Can we not do that? Oh, I see what this is. Check that out.
Right, so,
You'll get it.
the directions here are crucial. It says find each derivative. This is a limit though, right? Why is this a derivative? It's how you find a derivative, right? Don't you remember? This is the limit definition of the derivative, okay? This is like f of x plus h minus f of x all over h as h approaches 0, okay? Since it does not say to use the limit definition to find the derivative, we don't actually have to sit here and try to evaluate by getting a common denominator and then combining like terms. We don't need to do that. All we need to do is pull out of this what the original function is and then take that original function's derivative. What is the original function here? Huh? E to the x over x. Exactly right. How do we know that? Because remember, the original limit definition of the derivative is the limit as delta x approaches 0, or h approaches 0 in this case, of f of x plus delta x minus f of x all over delta x. F of x is the thing that's being subtracted here. So this quantity that's being subtracted is, that's it. Okay, that is f of x. Question? Or just stretching? Okay. Happens. Okay, so f prime of x then. Let's go to... Ooh, Nate. What do you say here, Nate? So it's the bottom. X times e to the x minus times 1. So if you want to just leave it e to the x or put a 1 there, that's fine. All over x squared. Beautiful. Very good, Nate. Okay.
Austin's like, I'm so getting this wrong.
Okay, now we have x e to the x. E to the x times 1 is e to the x. Bless you. All over x squared. Okay. We could do a little bit of simplification in the numerator by doing what? We could factor on e to the x, but that's not going to help very much at all. But if you like to, just to kind of make it look pretty. Don't have all those e to the x's in there, but there's the derivative. Okay?
Is that it?
There's your derivative. Or this one.
I'm
Either
going
one.
to get to this point in the quiz, and I'm just going to be like, no.
Okay.
Well, this isn't on the quiz now.
So, very good, Christian. Thank you for pointing out. This will not be on the quiz. However, if you come across a question that will allow you to use product rule or allow you to use quotient rule, feel free to use it.
I'm not going to. That's not
Okay?
Oh, that makes it a lot easier though.
Well, it's probably not gonna be even.
The problem is, put on there multiple times, you're supposed to do
Yeah.
All right, one more here. Limit of h approaches 0.
I have no room.
I'm just gonna wait till you write the whole thing out so I can see it.
Okay, so sorry, the limit is h approaches 0 of pi plus h over cosine pi plus h minus pi over cosine pi over h.
Wait a second.
Ooh, wait a second.
Well, pi over cosine of pi is
Excuse me.
what that matches to 0.
So what's our function here?
I'm gonna wait.
Pi over cosine pi. So the derivative will be bottom cosine pi times the derivative of the top. What's the derivative of pi? 0 minus the top pi times the derivative of cosine pi. 0 all over the bottom squared. So it's 0 is the answer. Which we could have just seen because what is pi divided by cosine pi? It's just a constant. It's a number. So the derivative of it should be 0. Wasn't even really necessary to do a
I was like, that's a constant.
Mr. Witt, what's up?
It was always going to be like the
Yes. Yes. And you can kind of see it here too, right? And if you just ignore the plus h's, it's there too. Pi over cosine pi. In fact, if you're like ever looking at it, you're like unsure about this side, like the right-hand side here, and if you're like, I'm not sure what the function is exactly, because the minus can kind of throw you off a little bit, look to the left-hand side and just ignore the plus h's, and that's your function. Like right here, ignore the plus h, it's e to the x. Ignore the plus h, it's e to the x over x. That's it. Okay. All right, one more little problem, and then we'll be done, which I think we should have just enough time for. How about that for timing, right? You guys, I know, right? Yeah, it's goodness gracious. This is a little marathon we got here going today. Sorry?
The practice problem.
We'll see. We'll see. It's a bit of a different kind of dealy. Assume that f of x
You know what assuming does.
and g of x, it helps you answer the problem, are differentiable functions. And some select values are given in the table below. What table below? I'm going to draw it. Okay. So x, f of x, g of x, g prime of x. Oh, sugar. Made a mistake.
I'm gonna get bug out when you're done with this wood.
Yeah, sorry, I meant to put a g prime.
No. They do.
F prime of x should be here, sorry. G of x should be here, and then g prime of x should be here.
Doesn't look as nice.
Okay?
I like it.
And so then we're going to put some x values down here, so we'll do like -2, -1, 0, 1, and 2. Made my table a little bit too big, that's okay. And we'll just fill in some numbers here. Nah, not random numbers, but they're from my notes here. Because you do have to do a little bit of prep for the way some of these work out. And I don't know. Okay. Okay. All that info.
Gotta make a song out of this.
I hate being a lefty and getting white out.
You might, yeah.
Or
I managed to smudge it even right-handed, so. No win. All right, so there's the table. Here's our first question. If P of x is equal to x times f of x, find P prime of 2.
P prime.
So this is a bit interesting problem, right? We have no idea what f of x actually is. We have some values for f in this table over here. And we are told about this other function, p, which is like x times f, but we don't know what f is. But somehow we're still supposed to find p prime. Let's think about that, what that would look like. So p prime here, to take the derivative of p, what do we have to do? We want to take the derivative of p, right? How are we going to take the derivative of this?
It's a product rule.
It's a product rule. It's a product rule. So it's the first, x, times the derivative of the second. What would we call the derivative of f?
F prime.
Yeah, f prime. Plus the second, f of x, times the derivative of the first. What's the derivative of x?
X prime. X prime. X prime. X prime. It's just 1.
It's 1.
Oh, yeah.
Because we're taking the derivative with respect to x, so the derivative of x with respect to x
So
is just 1.
Plus F.
So it's times 1. So yep. So then, now we have p prime. Let's find p prime of 2, which would be 2, and for the x, times f prime of 2 plus f of 2. Okay? So, Mac, what is f prime of 2? How'd you get that? The table. F prime of 2 is 5. What's f of 2, Mac? Negative 1. F of 2 is negative 1. So we get 9. Easy peasy. Okay, we'll do one more like that. This is a popular kind of like, this will show up once in a while on the AP test. Okay, problems like this where you get like a table of values. And the idea is just you're practicing your rules. Okay, so if q of x, and this will be our last one because, well, we're going to run out of time. But this is actually what I wanted to get through today, so I'm okay with that. Find q prime of negative 2. Okay, so Joey, how are we going to take the derivative? What's the derivative of q here, or q prime? What is that equal to? Three. Okay, g prime of x, and then times what? So, again, the derivative here, the product rule is the first times the derivative of the second. So it's going to be 3 times f of x, g prime of x, plus the second g of x, times the derivative of f prime of x. Okay, I know we're still getting that down, so there it is. I pulled 3 out there. Sorry, just for the interest of time there, I got to get through this. So q prime, then, of negative 2 is 3 times f of negative 2 times g prime of negative 2 plus g of negative 2 times f prime of negative 2. And then we just use our table. So f of negative 2 is 4. G prime of negative 2 is 6. G of negative 2 is 5. And f prime of negative 2 is negative 1. Sorry, we have questions? Drew, you said what? Alright, let me give you guys your assignment.
I understand how you do it.
Oh my gosh, yeah, I don't know where I got 15 from.
Sorry, it's 57. 57?
57.
I did it wrong.
Okay, here we go. Your homework. Remember, the quiz will not cover this stuff. Page 147 to 148, numbers 1 through 13 odd, and number 83.
I think my flash is off.
These take some space, though, because of all the work. Yep.
Would I ever assign
Yes.
that many problems? I hope not, for your sakes and my sake.